Hello guys, good day. Just enjoy watching this channel and it is called Humble Math. This channel is help you to voice your interest in dealing with such difficulties in mathematics. So as we go through with this, we have now the first lesson, which is solving quadratic equation using factoring or by factoring. This lesson is from grade 9 learning area. So as we go through, we have we have now solving quadratic equation by factoring. Then, and by the way, I will be thankful that this slide, as I search this one to the icon box engine of the Google Chrome, and I just modify it, and I am thankful that this one is flash from the was shared from the nice provider, and I am thankful for who you are. As posted in the screen, that one is my source. So we are now here on the first slide. So let's proceed to the second slide. Our second slide is the objective of this lesson. So the objective is of this lesson as we go through is just to solve the quadratic equation by factoring. Okay, take note, what is solving quadratic equation? When we talk about solving quadratic equation, we are looking for the value of a certain variable. That the certain equation is in the quadratic one. So there's so many ways in how to solve it. The one of it is through factoring. So we have the quadratic equation. We have to recall ourselves in working with a quadratic equation. So quadratic equation is written in the form of ax squared plus bx plus c is equal to 0. Take note that ax squared is what you call as quadratic term, bx as linear term, c as constant term. That a, b, and c are all numerical values that comes from all real numbers, provided that the value of a is not 0. Because if it is equal to 0, it's not anymore quadratic equation, and it is a linear equation. So again, what we have to do is you have to familiarize how to transform the certain quadratic equation into standard form, because that would be the very first step for us to work on in factoring. Here are some examples of the quadratic equation. We have x squared plus 5x plus 6 is equal to 0, and that one is written in the standard form because 0 on the right side, whereas x squared plus 5x plus 6 is quadratic expression but on the left side. So that is why the first given example is written in the standard form. While the second example, which is sec 2x squared minus 5x is equal to 3, is not written in the standard form, but it is a quadratic equation. Why? Because the degree of a certain variable is 2. So that is why quadratic equation. While on the next example, which is x squared equals 4, still the same, it is not written in the standard form. But then again, still quadratic equation. And take note that when we talk about solving quadratic equation by factoring, the very first move that we should do is to identify first if the quadratic equation is written in the standard form, so that we could go for the step 2. What this step 2 is all about, try to find ways how to factor it out, the quadratic equation, its expression on the left side. Okay, and we are going to try to understand the concept of zero factor property. What is this zero factor property? If a and b are real numbers, and if ab is equal to 0, then either a is equal to 0 or b is equal to 0. Take note that a, b here are both factors, and it is equivalent to 0. So either of the two must be 0. So because if we're going to multiply either of the two either of the two factors is 0, the result still 0, diba? So take note with that. Either of the two must be 0, or both may be 0. Okay, we are now go to the example number 1. We are using for the factored form a zero factor property. The word solve, or the word solve in a certain objective, or given the certain verb which is solved, is we're looking for the unknown valued, and that is represented by the variable. Okay, given example number 1, first problem of the example number 1 is quantity 2x plus 3 is times the quantity of 5x plus 7. Now, is equal to 0. As I said a while ago, it must be written in the standard form, but there is a twist alongside of the quadratic equation, and that example is represented by first example in the quadratic equation. Take note that the right side is 0, but on the left side is quadratic expression written in the factored form. So therefore, if that would be the case, we are automatically solve for the values of x by means of every factors, which is 2x plus 3 and 5x plus 7 must be equated to 0. So we have now the solution, 2x plus 3 equals 0, and or 5x plus 7 is equal to 0. Then, okay, in the first factor, which is 2x plus 3 is equal to 0, so we are going to solve for x by means of, the first thing that we should do is that we're looking for again, we're looking for a certain values of 3 to make it plus 3 to make it 0. So using the additive inverse of positive 3, which is negative 3, so add both sides by negative 3. So therefore we have now 2x plus 3 minus 3 is equal to 0 minus 3. So therefore we have now 2x as the value of 2x plus 3 minus 3, because 0, it make it 0 already. So what we have now is 2x. On the right side of the equation, so we have 0 minus 3, and that is negative 3. To solve for x, so we are going to divide both sides by 2, because our main task here is to make it multiplicative. We have to encounter the multiplicative identity of 2x, which is how divide both sides divide both sides by 2 to make it x on the left side. So we have now x, and so we have on the right side of the equation is negative 3 over 2, and so we have negative 3 over 2 as the value of the first x. So for the second factor, so we have 5x plus 7 equals 0, and so we have uh, 5x plus 7 minus 7 equals 0 minus 7, because what we have now is we are looking for the additive inverse of plus 7. So that is why we have add both sides by negative 7. So what we have now is 5x, and it is equivalent to negative 7. So divide both sides by 5 to have x on the left side of the equation. So now we have x is equal to negative 7 over 5, because negative 7 over 5 cannot be reduced anymore. So that is why we have negative 7 over 5 as the value of the second x. So we are now claimed that the value of x is equal to the set negative 3 over 2, negative 7 over 5. Okay, why is it that it is written in the set builder 1? Because there's so many ways in how to write this one. One of it is through roster or through set builder form. It's still the same, or it is also correct. No worry about it. Okay, so now we have for example number 2. So we are now proceeding to the example number 2 for the first example. So we have x times the quantity of x plus 4 equals 0. Take note again, This one is written in the the given problem is quadratic equation, but written in the factored form. Why? Because the left side is factored and the right side is 0. So automatically, we have to set every factors to be 0. And so, we have x equals 0 and the other one is 2x plus 4 equals 0. So, we could not go over with the first factor because it is already 0. Take note with that. And we should proceed now to 2x plus 4 equals 0. So, we have, again, set this positive 4 to make it 0. So, we add both sides by negative 4. So we have now 2x plus 4 minus 4 is equal to 0 minus 4. And so, what we have now is 2x is equal to negative 4. So for x, so using the distributive property of equality, so divide both sides by 2. So we have now x is equal to negative 2. Okay? So the value now of x is equal to set 0, negative 2. Any further hardship of this? If none, okay, just comment in the icon box of my YouTube channel. Just comment it, okay? For me to be able to know if you have some awkward thing in this problem. Okay, let's proceed to the next slide. Okay, our given task for the second example is still the same, that we're looking for or solve for the value. If we have here a certain objective or instruction, if it is solved, we're looking for the value of the unknown. And then in this example, we are representing the value of x as the unknown variable. So we have now given first problem for the example 2, which is x squared plus 2x is equal to 8. Take note that the right side of the given example is not written in the standard form. So the first thing that we should do regarding this case or regarding this example is we're setting that one, or just transform that one from non-standard form to its standard form, and that is must be written into x squared plus bx plus c is equal to 0. Now, what do we do here is, since the 8 here, or the constant term, is on the right side of the equation, so we're going to set this 8 on the right side to make it 0. How it happens? So we could not, so that one, meaning we're going to set both sides, add both sides by negative 8. So we have now x squared plus 2x minus 8 is equal to 8 minus 8. And so we have now x squared plus 2x minus 8 is equal to 0. And then we have now quantity x plus 4 times the quantity of x minus 2 is equal to 0. So every factors will be equated to 0. So x plus 4 equals 0, or x minus 2 equals 0. So we have now set the plus 4 to make it 0. So we have to add both sides by negative 4 on this first factor. So we have x plus 4 minus 4 is equal to 0 minus 4. So therefore x is equal to negative 4. Then the other one is x minus 2 equals 0. So we have x minus 2 plus 2 is equal to 0 plus 2. Set negative 2 to make it 0. So we're going to add both sides by 2. So we have now x is equal to 2. So we have x is equal to set negative 4, 2. And now we are in the second problem of example number 2, and that is still the same, that we are solved. So we are looking for the value of a certain x. From the given, x squared is equal to x plus 30. Take note that the right side of the equation, x plus 30 as the value. Since that one is not written in the standard form, and at the same time it is not written in the factored form, which is not equal to 0 as in the right side, so therefore we're going to set the right side of the equation, which is x plus 30, to make it 0. So the additive inverse of x plus 30 is negative times the quantity of x plus 30. So as you notice, we're adding both sides by negative quantity x plus 30. So from this is we're going to have now as the first step x squared minus quantity x plus 30 is equal to x plus 30 minus the quantity of x plus 30. So the right side of the equation now is equal to 0, and on the left side now it became x squared minus x minus 30, because negative times x is negative x, negative times 30 is negative 30. So we have now x squared minus x minus 30 is equal to 0. So the factor of this one now, since the quadratic term, the numerical of the quadratic term is 1, so we're looking for the factors of negative 30. And its sum must be the same with the middle term, which is negative 1. So therefore, the factors of negative 30 rather, is negative 6 and 5. Because if we're going to add negative 6 and 5, it would come up negative 1, which is the same with the middle. And so we have quantity x minus 6 times the quantity of x plus 5 is equal to 0 as the factored form of the quadratic equation. And so the next step is we're going to set every factor to make the 0. So as you notice, we have now x minus 6 is equal to 0, and the other one is x plus 5 is equal to 0. So we're solving for the first value of x from x minus 6 is equal to 0. So we have now x minus 6 plus 6 is equal to 0 plus 6, because we're set negative 6 as we go through to make it 0. So the additive inverse of negative 6 to make it 0, so we have plus 6. So that is why both sides of the equation be added by plus 6. So we have now that. And so negative x minus 6 plus 6 is, we have now x, 0 plus 6, and we have here 6. So the value of x now here is 6. While on the other side, we have x plus 5 equals 0. So what we have now is to make it 0, the plus 5 here. So we are going to add both sides by negative 5, the additive inverse of positive 5. So we have now x plus 5 minus 5 is equal to 0 minus 5. And so from x plus 5 minus 5, we have now x, because 5 minus 5 is 0. So x plus 0 is x. 0 plus negative 5, or 0 minus 5, is negative 5. So we could now have the value of x is equal to set negative 5, 6. That is the second example for the example number 2. The second problem for example number 2. In solving the quadratic equation using factoring or by factoring. Step 1, write the equation in standard form. That is, in all terms, on one side of the equation equals descending power of the variable, and the other side must be 0. And take note, if the quadratic equation is written in the factored form, then the right side is 0, then equate automatically to 0 every factors, as what we have in example number 1. Now, step 2 is factor completely, so we must be knowledgeable enough and how to factor it out. Step 3, use the zero factor property to set each factor with variable equal to 0 and solve the resulting equations. Then step 4 is we're going to check if the original equation if each solution is already equal by means of its original equation. Okay, what we have now in example number 3 is still the same, but we are looking for the solution value of m now, not anymore x. Again, as I said, we're not only using variable x as we find out. Take note that all letters or in the English alphabet is what do you call it, a known value. So we are looking for the certain value of that in part of the English alphabet. What I mean is the letter to represent the certain variables. Okay? Or the certain variable that we have. Okay, we have here example number 3. Solve 3m squared minus 9m is equal to 30. Okay, the first thing that we should do is set the certain quadratic equation to make it standard form. So we have now add both sides by negative 30 to make it 0 the right side, because 30 minus 30 is 0. Then 3m squared minus 9m minus 30 is equal to 0. And so we have now that, and multiply both sides. Okay, we have to, since every terms here has a common factor which is 3, so get the common factor. So 3 times the quantity of m squared minus 3m minus 10, which is equal to 0. Why make it m squared minus 3m minus 10? Because 3m squared divided by 3 is m squared. Negative 9m divided by 3 is equal to negative 3m. Negative 30 divided by 3 is negative 10, which is equal to 0. So we have now 3 times the quantity of m plus 2 minus 5 3 times the quantity of m plus 2 times the quantity of m minus 5. Take note that the 3 here is a common factor. If we're going to divide both sides by 3, so we have now m plus 2 times the quantity of m minus 5. So every factors must be equated to 0. So we have now, first is m plus 2 equals 0, and the other one is m minus 5 is equal to 0. Then we're going to work it out that the plus 2 here must be 0 as we go through. So we are going to add both sides by negative 2. So we have now m plus 2 minus 2 is equal to 0 minus 2. So we have m is equal to negative 2 now. And the other one is m minus 5 equals 0. So set the negative 5 as we go through to make it 0. So we are going to add both sides by positive 5. So we have now m minus 5 plus 5 is equal to 0 plus 5. So we have m is equal to 5 now. So the value of m that we have now is, we have instead negative 2, 5. Take note that a common error is to include the common factor 3 as a solution. Only factors containing variables lead to solutions. Okay, take note, what does it mean by that? Since 3 is a constant number, then as it says there, if we are going to make use of the factored form, every factor will be equated to 0. Then take note that 3 is not equal to 0. If we take every factors will be take it to 0. So we are going to eliminate or ignore the 3 there. So that is why those factors having a term of a variable, so those factors must be equated to 0, not included the numerical value as the common factor as we go through, as you notice in our example number 3. Okay, another one is we have solve for 49x squared minus 9 is equal to 0. Then again, the given example is equated to 0 na, and so that one is written in the standard form, but we don't have a linear term. Take note, we don't have a linear term, but take note the quadratic term, which is 49x squared, is a perfect square of 7x, while the 9 is also a perfect square of 3. Then we have binomial term difference of two terms. If that would be the case, we have a factor which is we have to recall ourselves in factoring difference of two squares. So we have quantity 7 plus x times the quantity of 7 minus x is equal to 0. Then equate both factors to be 0. So we have 7x minus 3 is equal to 0, and the other one is 7x plus 3 is equal to 0. Then we have to remove the negative 3, or make it 0 the negative 3 rather. Add both sides by 3. So we have now 7x, which is equal to 3. Then to solve for x, so divide both sides by 7. So x now is equal to 3 over 7. Well, on the other hand, the second factor, which is 7x minus 3, so we have 7x plus 3 rather. So we have 7x plus 3 minus 3 is equal to 0 minus 3. So set the plus 3 make it 0. So we are going to add both sides by negative 3. So we have now 7x is equal to negative 3. So divide both sides by 7. So we have now x as the value here, which is equal to negative 3 over 7. So therefore, the value of x now is set negative 3, 7, 3 over 7. We have two values of x in this example. Next example is we have x squared is equal to 3x. Again, we have here an example, x squared is equal to 3x. So, since in this example is not set yet into standard form, so we are going to equate and we have to make it sure that one is written in standard form. So we have now to make it 0, the 3x, because the 3x in the right side is in the right side of the equation. So therefore, we're going to add both sides by negative 3x. So we have now x squared minus 3x is equal to 3x minus 3x. So the right side now is 0. So why do we have here? Take note that x squared minus 3x having a common factor, which is x. So take the common factor x, the common monomial factor. Then how to get the next factor is we have x squared divided by x is x, negative 3x divided by x, from the first factor is x minus 3, so or negative 3. So therefore we have now x times the quantity of x minus 3, which is equal to 0. So every variable set to 0, so x is equal to 0, and the other one is x minus 3 is equal to 0. Then since we are looking for the value of x, so add both sides by 3. So we have now x minus 3 plus 3 is equal to 0 plus 3. And so x now is 3. So the value of x for the second problem of the example number 2 is 0, 3. Okay, the continued example for the example number 4 is we have here solve x times the quantity of 4x plus 7 is equal to 2. Take note that we have now a factored form on the left side and the right side having 2. We could not take it go over with the factor we could not go with the factor that could make it equated to 0. So in short, expand first and transform into quadratic equation as a standard form. So x times 4x is 4x squared, x times 7 is 7x is equal to 2. Since we have 2 in the right side, so add both sides by negative 2, add both sides of the equation by negative 2, so that the 2 there on the right side must be 0. So we have now 4x squared plus 7x minus 2 is equal to 0. Then factor the 4x squared plus 7x minus 2 equals 0. So we have now x times x, a quantity x plus 2 times the quantity of 4x minus 1 is equal to 0. Okay, I will make another video lesson on how to factor of different quadratic expression. Okay, for you to enhance or to recall yourself how to factor quadratic equation at quadratic expression. And so we have x plus 2 is equal to 0. So we have x plus 2 minus 2 is equal to 0 minus 2, because we're setting plus 2 to make it 0, so that we could remain, the left side must be, the remaining value for the left side is x. Then 0 minus x, 0 minus 2 is negative 2. And the other factor must be, as I said, will be equated to 0. So therefore we have 4x minus 1 is equal to 0. So set negative 1 to make it 0. So add both sides by 1. Both sides of the equation. So it became 4x minus 1 plus 1 is equal to 0 plus 1. And so we have 4x is equal to 1. So divide both sides by 4. Then x is equal to 1/4. So the value of x here now is set negative 2, 1 over 4. Okay, then again, as we have in the given topic of the solving quadratic equation by factoring is worth remarkable. Take note that I hope that this video lesson will help you throughout this subject, grade 9 subject. Okay, if you have some question, just comment in our channel. Then don't forget to subscribe. Click the subscribe button and click the notification bell. Have a good day. Goodbye.